Hey,
Hello.
hello.
Welcome to You Choose, a choose your own adventure style journey through the CNCF landscape. We did it, Victor.
What did we
Almost.
do?
We made it through chapter 5. We made it through the 5th season of You Choose.
Okay, because it sounded like we did it. This is the last one. Finally done. No more of this nonsense. Okay, now I
No,
understand it better.
more and more nonsense, please. But I would like a break from the nonsense after this episode. We're gonna. This one, we're going to recap everything we talked about throughout chapter 5. So it's a longer episode than usual. Get some popcorn, a pillow, relax. We're gonna be here a while. Victor, what are we're building, this is a platform, internal developer platform. This is what we've been talking about this whole time. What problem are we even solving? Did we spend the last 2 months solving?
I mean, we are solving the problem that platforms in general solve, and that's how do you enable people to consume the services you provide for them, right? How do we build those services? How do we run those services? How do we people to those services? And since there is a word internal, we're not building a general public AWS like service or platform. We are building something that is for the people working in a specific company.
I'm drawing, I have a light board with me today, which we decided to start last season. So I have some app teams that I'm drawing. And the problem, so we want to enable these app teams to be able to do what exactly?
I'm going to answer in cryptic terms, to do the stuff that is outside their core competency.
Aha. So
Right. So if you have a person that is specialized in writing code for Node.js, I don't think that person needs much help with that, right? But that person might actually not have spent 75 years learning Kubernetes, and we might want to help with that. Or maybe it's not that experienced with databases, and we might want to help with that, and so on and so forth, right? So it's a different way to explain it is, how can we convert somebody's experience into a service so that somebody who is less experienced with that something can consume it, right? You're a database expert, you know databases inside out. You have two options in front of you. People send you emails asking for something, or you convert it into a service, plug it into that platform and say, okay, now you can do it yourself in a relatively easy way. It cannot be hard, because if it's hard, then people need first to become the same expert as you are.
So over here, I drew various app teams. And before platform engineering existed, the app teams were themselves trying each one separately, where it's coming up with their own solution for all kinds of things, for how they're going to collect and show metrics, maybe for a freaking CI/CD pipeline, for their databases, for their Kubernetes cluster that they're using for development. They're doing all of that themselves.
Sometimes.
More
often than not, they would open Jira ticket to somebody else and say,
okay.
I need this. And then the outcome of that highly dependent on whether that person who wrote a Jira ticket is religious or no.
Wait.
Because if that person is religious, then prayer can help a lot. If not, then depression while waiting.
So before platforms, it was like, I'm going to send a ticket or a message somehow to the expert to get what I want. The expert's going to take time to manually provision what the app team needs. And then
doesn't have to be manual. That person, that's a black box for you, right? That person might be doing it using Terraform, might be doing it manually, might be using witchcraft in sorcery. You don't know. All you know is that you requested something, and sometime in the future it might come.
So I'd say that is part of it, but I would say there's a lot that the app teams doing that operations could, or platform teams help with. Do you disagree with that? Like the app teams were considering how they're going to do their own development environment they were having to learn some Kubernetes. For example,
learning some Kubernetes, that's similar to, I learned some development, but I still don't know what I'm doing.
Yes. I didn't say they're doing a good job of it, but I said they were doing it.
There might be, yeah.
It definitely isn't part of their core, like what you said, like their value, like what they are good at. But I'd say to deal with these more and more complex environments, there's doing some mix of asking experts, some mix of using managed services, some mix of doing some stuff on their own that they maybe didn't need to do. And a platform is coming in to reduce all the toil around all those different areas. That's what platform engineering does. Yeah?
Yeah.
So that's platform itself, and platform engineers and platform team is solving the problem of tons of tooling complexity and being able to streamline that to reduce toil, but then also to add reliability and security to your system by having consistent building blocks that everyone can agree on. Yeah. And here's a question.
By the way, for listeners, when I start saying that's because I get bored with whatever she's saying and I'm not listening anymore, I say yes.
It's not that I'm right. Here's something. If you're like committed to the show enough to watch this finale, I want you to know that almost every time I ask Victor a question, I already know the answer to the question. I just want to hear his take, and then I'm going to make sure the right points that I think are important are conveyed. But together we make a good team, Victor. You don't need to listen to me. It's cool.
Yeah.
So the first step in our first episode in making a platform happen and in solving this problem is that we need to build APIs and manage state or manage state. So what do APIs have to do with the platform?
I wouldn't say that we have to build API. We don't.
Yeah.
Just as we don't have to live in 21st century, right? We can still kind of... now, the APIs is how we interact with public platforms, right? If you take any example, like whatever you're using, Azure or GCP or AWS or Linode or Datadog or Grafana, whatever you're using, public service, it's always through an API.
Yeah.
Right? Mm-hmm. And that might not seem obvious because you say, some people would say, no, I'm not using API. I'm using Terraform. Then you say, yeah, but what is Terraform using? Kind of, it's either API of that something or it's sorcery that I mentioned before. It's one of the two, right? So there is always an API in modern architecture, right? Between something consuming something else.
So a great example of that is the hyperscalers. Yeah. So like Google Cloud Platform, for example, you might use G Cloud, you might use the Web UI, but under all of that is you directly calling the Google Cloud API, and that's what these other tools are doing too. So APIs, putting our platform capabilities. So our platform needs to present platform capabilities to the app team. One thing I wanted to ask you is about, should the app teams be forced to use these capabilities?
They shouldn't. Oh, of course they shouldn't. Nobody should ever be forced. So
mandated is a nicer word to say that, yeah.
If you ask a different question and say, are they forced to use it in real life? The answer is very often yes. And that is very unfortunate, right? But they shouldn't be, because among other reasons, there are obvious reasons like, hey, if you're forced to do something against your will, you're not very happy, and unhappy people don't do a very good job, and so on and so forth. But it's more about, how do you know that what you did, which parts of what you did is good and which parts are not, if you don't have feedback? And willing adoption of something is probably the best feedback you can get, right?
We need it to be optional to be able to force to get the feedback of whether or not it's being used. And it's
because think of it this way, right? If it's mandatory, it's mandatory. Everybody has to use it, and that's it, right? Now, if it's optional, and there are two options. People prefer use it, and you say, this is great. People are using it willingly. Kind of how amazing is that? Mm-hmm. Or people are not using it, and then you can ask yourself, why? Why do they prefer to invest their own time to build something that I already built for them? Right? And the logical answer is, if somebody is willing to manage something themselves instead of using your service, that means that your service is terrible. It's so horrible that somebody prefers investing days or weeks instead of what you perceive as being 5 minutes experience, right?
It could also mean that they just don't know about it. So that could be your problem as opposed to having made something bad. And
it could be, but again, right, kind of like you see that through adoption, okay? And then you ask people questions, kind of like, okay, why aren't you using it? Right? You treat it like any other product, public product, right? Why aren't, I didn't know that there is such a thing. Great, now I know what to do. I need to actually do marketing, internal marketing for it, or this is horrible, right? And then you know that you can ask follow-up questions like, why is it horrible? Oh, because it's horrible because it's doing something completely different than what I need or what's not, right?
The other reason maybe that they wouldn't use it is because some app team is making some very specialized application that has special requirements, and the platform team hasn't built something that takes care of those requirements by design. Yeah,
the point is never, so imagine that we are talking about now a startup, a company, right? You don't try to become a solution for everybody. That never works, right? You go for 80-20 rule, right? What is it that I can do with 20% of my time that will satisfy the need of 80% of the people, knowing that you will need other 80% of your time to satisfy the rest of the 20% of the people, right? And that's not a worthwhile investment. So it's never what everybody needs, because, there is a single person somewhere in your company that needs something that nobody else needs. Well, what's the point of building it for that person? That person can do it himself or herself. I should focus on what satisfies the needs of larger number or larger percentage of people in my company.
So we're looking for use cases or capabilities to build that are broad, required, and undifferentiated, that basically help the maximum amount of teams with the least amount of effort from the engineering team.
There we go.
And so we're going to start our journey by building APIs, and presumably we've talked with application teams first to see what they need before we decide which API to build. And our hypothetically with the company, and you choose. Yeah.
Everything I will do today and demo assumes that I did those conversations, right?
Yeah.
Kind of imagine that I know exactly what they need, which is never the case in the first attempt. You need to fail infinite number of times until you figure it out, like any other product. But let's assume that we passed that stage.
So we're going to put it behind APIs. APIs can have the guardrails, which we'll build part of today. The security can be invisible then to whoever's consuming it, which is great. APIs are building blocks that can be wrapped in several different interfaces. APIs are cool because they can be composed with one another to make more advanced use cases. APIs are cool. Here's something. We build today on Kubernetes. Do you think a platform should always be built on Kubernetes?
Yes, 100%. There is no alternative to Kubernetes to build a platform.
Yeah.
Now, that does not necessarily mean that what that platform is doing is in Kubernetes. There is a difference between where is my platform and what my platform is doing.
Why should it be in Kubernetes? The platform itself be Kubernetes?
Many reasons. First, because it's the standard. It's the first time in the history of this industry that most of us, and vast majority of vendors and projects agree that this is the base on top of which I will build solutions. So the building blocks that you need are in Kubernetes, and optionally, some of them might be outside. Second, because Kubernetes has the building blocks that we need, like, hey, how do you create API? It's very easy by extending Kubernetes through CRDs. How do we manage our services? Well, there are controllers in Kubernetes that do that, and so on and so forth, right? So both because it's a standard that is more adopted by far than all other standards together, because there are solutions for it that outnumber solutions for any other platform, and because it provides the means to do stuff that otherwise would be much more complicated.
So we're building a platform in Kubernetes. The capabilities aren't necessarily Kubernetes. But the platform itself is important to be Kubernetes because it's an industry standard. You can use it to manage states because it has the synchronization loop, and because there's a badass ecosystem of all kinds of tools that you can use to help.
Correct.
Which is basically what we're going through today. All right, so we need to build or use APIs and manage state as the first thing we're doing for our platform as part of You Choose. And for episode 1, we had on 3 projects. We had on Kubevela, Crossplane, and Cradix for those.
Yes. And I will mention the 4th project that we didn't include, but it's there as well. There is Crow, which was released relatively recently, right? Which they all do similar stuff.
And Crow is KRO. And
KRO.
AWS.
Kubernetes Resource something.
Orchestrator, maybe?
Let's go with that.
I like it. So do we want to talk about what differentiates those tools from each other?
So, a short version.
Yeah.
Cradix, I don't know in depth, so I cannot say much. Kubevela, good attempt that is based on top of open application model that happened never to see wide adoption. And Crossplane, I'm very biased. So, it's the best. I work in the Crossplane project, so I'm biased.
Kubevela is more about applications, like having a way to deploy applications. It's
I
not
think
really
that's
about
silly.
Building the infrastructural elements.
I think that all those distinctions, this is for applications and this is for infrastructure and this is for something else, I think that they're all silly. Because what all those tools do, not exclusively, but the important part that we are talking about today is that they create APIs, right, that provide the abstraction that you need for your service. And they manage or compose resources that you want. So, hey, I create a service that is database, and for database we need networking, with storage we need this, we need that, right? Kind of compose the resources, which, since we are building it on top of Kubernetes, are Kubernetes resources, right? Mm-hmm. Now, whether those resources happen to be something related to applications or something related to infrastructure or something related to something else is not important here, right? All those tools do 2 things, among other things: create APIs and compose resources, the low-level resources from the higher-level abstractions, right? That's what they do. It's up to you to choose whether it's used for applications, for infrastructure, or for whatever you want. Now, there is one thing important here. When I say resources in this context, I mean resources in terms of something that has a state, right? There are other types of services that are either part of the first group or separate, that are managing some operations, some actions, right? We're going to get to that later. But for now, when I say resources, I mean something with state, like database or cluster or application.
So you're saying build an API, and you're not wrong, but in Kubella's case, you don't actually build an API. You use the application abstraction that they provide as part
So
of it.
you don't build a new API endpoints, which is one of my complaints about Kubevela, but you do define how that existing endpoint in Kubevela is called application can be extended through components and
Traits. Yeah.
and traits. Yeah, so you don't build new API endpoints, but you do define how the existing and the only one you can use with Kubevela behaves or how it can be extended. You extend existing APIs without creating new ones.
And then my understanding of crossplane versus Kratix, I think crossplane can do literally anything. Literally anything that exists can be brought into Kubernetes, and then you can use Kubernetes to manage any resource on the planet. And you can take those resources and compose them with one another to make a full-fledged solution. And I think Kratix maybe lives in that world, but they do a little less somehow, but then they provide abstractions for operators too, to make the operator experience also easier. As opposed to crossplane, where the operator has a lot, the platform engineer has a lot to worry about, but then can do really cool stuff.
Maybe. I'm not deep into Kratix, and I tend to not comment much on the things I'm not very familiar with. So you probably know more about it than me.
Okay. So
mostly because you paid attention in the episode where actually Kratix folks explained what it is.
I do my best, but also that episode was in January, so we do what we can. So that said, let's get to the demo. Which technology won the vote, and which one are you going to demo right now?
Yeah, Kratix won the vote, so
Kratix
let's do that one.
Really?
Sorry, what did I say? Kratix, crossplane, of course. See how little attention I'm paying. Yeah, crossplane. Cut, editor, cut. Repeat. Crossplane won the vote. It's public, right. So it's not that I'm cheating. You can see it there in Slack. Okay, so let's bring
sure
my.
Yeah.
Yeah, let me put my screen. Cool. There's my screen.
Awesome. There it is. Okay.
Let's do it. So I already installed Crossplane and other tools, just not to bother you with the details. So over here I have, and I already created a repository for an application, right? So I have a repository which is different than the one I have, and I created it in advance with Crossplane. You can see it here. I have something called GitHub claim, which is basically that abstraction, and that one created a branch in my repo and a pull request and a bunch of files in the repo itself, right? That's not really what matters. What matters is that I will go to that repository of my application, and I will show you the source code. This is application written in Go, nothing really special over here. And I will copy 2 files without even showing you what those files are. And I'm going to apply both of those files to the cluster. I'm doing what shouldn't be done. I'm doing kube control apply. Never do that, but we'll get to that part later. And while this is now being processed by my platform, in this case Crossplane, I will show you what I did, right? So I created my own abstraction. You see that it's my own because the API is DevOps I created something called SQL claim for people to manage databases. And through labels, I let them select where do they want the database, in this case AWS, and what type of the database, PostgreSQL, and some parameters, right? So this is the core of that interface. Hey, you don't need to worry about it. Just tell me the things that you care about. And in this case, that would be hypothetical case version, the size. I want small database. I don't know what is small in AWS. I just want it to be small. This is the region, and I want to have 2 databases in that server, right? As easy as it can get. And I already applied it to the cluster. We'll see later how better to apply it, but for now that should be fine. And if you take a look at what's happening in a cluster, you can see that from that YAML, like 20 lines of YAML, Crossplane composed all the resources it needs. Like there is internet gateway in AWS, main route table association that nobody knows what it is. Some route table association because having main route is not enough, and so on and so forth, right? It even created some objects, meaning some Kubernetes resources that will create, in this case, a secret, and it will create 2 databases in that server, and so on and so forth. The one that really matters is this one. This is the RDS itself in AWS, right? And a lot of failures here. That's okay, because some things cannot be done before some other things, so it will try again in the future. It cannot do some stuff because database server, RDS, is still in a process of being created. It takes a while. Now, I'm not here to talk about databases. I just need a database for my application, but it's all about applications. So I'm going to copy another file. I'm going to apply it first. And then while it's being processed, I'm going to show you what I applied, right? So this is a second API that is, hey, if you need a database in Kubernetes, don't worry about it. Just use something called appclaim, right? My interface. Select what you want. You want backend application. There can be others like frontend, what's or not. And parameters, like I want to run it in production. I want this image. I want this tag, and so on and so forth, right? Nothing really special. I mean, in terms of interface, right? Relatively simple. Only the things that matter to people without going into all low-level details. And the important thing here is that among other things, I'm saying, hey, I want to connect to the database, and there should be some secret called silly demo DB created with the previous one. That's how you connect to it, right? And if I take a look at what we got, there is ingress was created, deployment was created, the deployment created replica set created pods, there is a service, and that's about it. Very simple one, right? Now, the application itself is not working, just to make it 100% clear. And it's not working simply because I applied an interface that simplifies management of applications for me as a developer, and that created low-level resources, whatever they are, but nobody yet built even a single image for that application, right? So there are resources in Kubernetes, but there is no container image yet. We'll get to that later. So it will continue failing, and that's fine. Similarly, if you don't want to use, you can see also, if you do tracing, you can see what are all the stuff that was assembled by Crossplane. Like apart from service and ingress and deployment that I mentioned earlier, there is also, it created a new branch in the repo. It created a pull request with all the additional files it needs and a couple of additional files. So everything related to application. That's the point. Now, if I do GHPR list, you will see that among other things, it created a new pull request in my repo with the stuff needed for that application. And I'm going to show you what that pull request is. All that is happening through those 20 lines of YAML, right? It created a Docker file that we will use later to build the image. It created debugs because I'm a freak and I like using it, and .nu, which is new shell script that will help with building, testing, and everything, right? You're in control. You decide, these are my choices. Don't judge me, right? And if I merge that pull request and I pull the latest changes, you will see that now I have those additional files. Apart from running stuff in Kubernetes, it also applied something in GitHub. And now, since my application is not yet running, and it's not running because I haven't built the image, I'm going to delete what we did and come back to it later when we figure out how to build images, right? And that's about it for that part, for building APIs and controllers that do stuff.
So what does the GitHub branch have?
So GitHub branch has So the idea is that to have everything related to application, but not only resources in Kubernetes, but stuff that you need in your Git repository. And that GitHub branch was created with, among other things, with Docker files so that you can build an image somehow, right? For that specific application. So basically it created files that you need to work with that application in the GitHub repo of your application.
Is it related to GitOps?
Yes, it's among other things related to GitOps, but it's also related to building images and testing your stuff and a few other things that we are going to go later when we go through Tekton and Argo workflows, CI. So CI part.
Okay. Those of you watching, none of this is planned, and we don't talk to each other beforehand at all about what we're going to say or draw. So we're making it up as we go. So I tried to kind of capture some of that on the board. So this
Well, good luck, because even I don't know what I said.
So you're building basically an API, just like we talked about we need, and this API has everything needed to deploy an application. And so you showed an AWS database that's being consumed as part of the API. So that's the first API you created, which includes all kinds of complex details that our app teams doesn't have to worry about, like the VPC, route table, gateway, etc. And then that AWS database is being consumed by a cross-plane app claim. And that's an API that you're building with cross-plane that has the application configuration. It has a reference to an application image, which isn't being pulled right now. It has that GitHub branch that you talked about that's going to help with CI later for building, testing, and GitOps. Is that?
The only thing I will add just for clarification is that there's a lot of stuff that I'm not showing, like how to build all that stuff. That would take a lot of time, right? So I assume that kind of like I already built those compositions, how we call them in Crossplane.
Okay. And then I left room because I thought maybe there'll be some more that goes in there as we go. Like, for example, the next thing we're going to talk about is policy. So now, once we're done, we're going to have, the app team is going to be able to provision a cross-plane app claim and get a running application, correct? Connected to a database. The finished product of our platform today is going to be that an app team can create an instance of this cross-plane app claim. And then they have a running application connected to a
beautiful web UI. Yes.
Through a beautiful web UI.
Full of colors and buttons.
Excellent. And so what we need to do next is add some security or add some policy to this app claim API that we're creating.
Yes, absolutely. We need to kind of figure out what is acceptable and what. So now the fact that we created a new API endpoint, we already restricted what can and cannot be done, right? Because I cannot put a field in that YAML that doesn't exist in the schema, right? In the spec. Yeah. So we already restricted just by creating APIs. Every API has a schema. We already restricted. Hey, this field is an integer. Kubernetes itself will say that you cannot put a string there, right? Or this field does not exist. Kubernetes itself will tell you that. Now, with policies, what we want is to fine-tune those, not restrictions, but guidances, right? What can be done and what cannot, because let's say we are using databases, right? And we have databases in production and databases not in production. And then we might have the differences, even though the schema is the same. Like, databases can be massively big in production, but we only allow you to specify small database, to use small databases in non-production environment, right? So those types of restrictions or policies that are outside of the schema that we built in the first place.
So some of the security is built in just because there's a schema and you can't just make stuff up out of nowhere.
Yeah.
But then for stuff that's not built in, that's when you can use Kyverno, or we've been talking about validating in mission policy.
Yes.
or Opiate Gatekeeper or Kubernetes or any of those to be able to make organization-specific rules about what can and cannot be done with this resource.
Correct. Just
And
as you
so-
know, when you go to AWS, if you say, I want EC2 instance, it will ask you in which region. And if you say Victor Landia, it will say no. We have a policy that that's not allowed, right? It can be US East, US West, this or that. It cannot be Victor Landia, right? Because we have a policy, whatever the technology is, that allows you to do only those regions, right?
And policies can be about security, but they could also be about like cost, kind of like what you said. You can't have a large database in development or whatever. Or they could be about automation, like if you create a new namespace, it automatically creates whatever.
Yeah.
Governance, that sort of thing.
You could have a policy that says, you know what, I don't care whether you create small or big. What I will give you is, 20 CPUs for databases. You can create one of 20 CPUs or 20 databases with one CPU, but you cannot go above that number. So it doesn't have to be even related to a specific instance of something.
Okay. So when we went through You Choose this time around, we just went with Kyverno because we've already done an episode around cluster level policy back in the security chapter that we did. So I think we can just hop right into the Kyverno demo, unless you want to talk about validating admission policy, which didn't exist back when we did.
No, this is amazing because I thought that we voted on it. I forgot what was the winner, so I prepared all of them. So now I know that it's Kyverno. Cool.
It's Kyverno.
You see, sometimes I would do less work if I would get informed myself. Okay,
Yeah.
Kyverno.
Show us Kyverno.
Yeah, let's go for it. Okay, so here is one policy that I have, right? And that policy is Kyverno. It's cluster level policy, meaning that it applies to anything in a cluster unless we say otherwise. And there are a couple of policies inside of them. Mm-hmm. Now, you can see by the name, scaling enabled. What that really means is that if somebody tries to create or update something called appclaim, which is our application interface, then evaluate that something, right? And the evaluation is, you know what? First of all, you need to have the scaling parameter set to true. It has to exist, first of all, right? And if it exists, it needs to have the sub-parameter enabled defined as well. And if it does have it defined, it needs to be true, right? So in other words, you need to set the scaling enable to true. Mm-hmm. And then for the same resource appclaim and for the same operations create and update, you need to have scaling parameter. And if you do, the minimum number of replicas needs to be greater than 1. Right? Relatively easy and straightforward rules. So what I'm going to do is I'm going to apply that policy to the cluster. I'm going to inform Kubernetes that from now on, ignore this warning, right? Because that's what we do. If it's not error, you just ignore everything. Now, if I try to apply the application that I applied earlier and then deleted, let's see what happens, right? Now, Kubernetes itself, API, rejected it. So it never even reached the cluster. It was rejected by the API itself. And I got messages, you know what, Victor, you're an idiot. Don't you know that scaling enabled must be set to true and that minimum number of replicas must be greater than 1? I said, cool. Got the message. Don't call me idiot. I'm going to modify my application. I'm going to add the spec parameter scaling enable set to true to the manifest, right? So if I now list it, apps silly demo YAML, you can see that now scaling enabled is set to true. Cool. I took your advice and I applied it to my application. And if I try to apply to the cluster again, it fails again. But this time only with one error message. Hey, Victor, you're still an idiot. You forgot to put this minimum number of replicas to something greater than 1. And I'm going to fix that, modify the manifest again. I'm going to apply it again. And now it says, yeah, okay, now you're good to go. You meet the requirements we set for specific values, what's or not. You're good to go, right? And now, if and that's about it, right? I got the policies. I'm going to delete the application. No, actually, I'm going to keep it. Policies are there. Rejoice.
So our policy makes sure that it scales greater to 1 and scaling's enabled. And then that itself is a Kubernetes API in Kyverno.
I think it should be like this. No.
Perfect.
Like that. I don't know how to do it.
You got it.
There we go.
So we have a Kubernetes API that is a Kyverno policy for scaling app claim around scaling. That's what you just made.
Mm-hmm.
And then we need GitOps is the next thing, which we also did as part of episode 2, and we've also covered already this time in chapter 2 around production. And why is GitOps an important part of a platform?
I wouldn't call it mandatory. The policies and APIs, among other things, I'm mentioning those two because we went through it. I would call them mandatory. No platform is without them. GitOps is not necessarily mandatory, but a really good addition, right? Because if everything is stored in Git, multiple reasons. First, you should keep stuff in Git instead of willy-nilly applying things from your laptop. Then we can see what was done and why it was done and how it was done. There are security reasons because then we can lock down the cluster and say, because, GitOps tools are all pool-based mechanism. They're pooling information from inside the cluster, so we can secure it by locking it down and a few other things, right? GitOps is a good thing.
GitOps is a good thing. It moves the threat boundary, so now nobody should interact with the Kubernetes cluster directly. Now they're going to interact from outside the Kubernetes cluster. And Argo CD is what the people chose years ago when we did that GitOps episode.
Yeah. So shall I jump into the demo?
Let's jump into the demo.
Okay, there we go. Okay, so I'm going to delete my application because I did it badly, right? I did kube control apply. This is my application. I'm going to start over using Argo CD. And I'm going to open it in a web UI. There we go. And if it works, I'm actually surprised that nothing failed so far. Admin 123. That's all my passwords are like that. Try it out. Okay, so I have Argo CD over there running. There is nothing inside, right? It's just running. And then first thing I need to do is tell it how to find my application, right? And I can do that with something like this. So this is an application resource, custom resource, like everything else in Kubernetes or almost everything. Argo CD application, basically, essentially what it does is tells Argo CD, you know what? You will find something in this repository, right? CNCF demo app. And that something will be in the directory apps, right? That's where we copied the application previously, manifest, by the way, right? And I want whatever you find there, I want it to be available in this cluster, which is the same cluster. And I want it to be in the production namespace. And I want you to do everything automatically, kind of synchronize, prune, delete, do everything that needs to be done without asking me questions, as long as that something is in that repository, right? And now, if I take a look at what I have in the production namespace, there is Nothing, right? You don't see it here because I have some silly dark theme, but trust me, it says no resources found in production. Now, if I apply this Argo CD application, which the only thing it does is goes to the Git repo and watches what's there, you will see a couple of things. First of all, if I bring you back the UI, because everybody likes pretty colors, here you go. You can see that it detected a new application called Silly Demo App. It detected that it's crossplane composition. It detected that there is app claim, and there are some other things I cannot see here because it's too small on my monitor. But anyways, it detected everything in that repo, everything we did so far. Those are the resources in this part, and this is now crossplane expanding, composing the low-level details, whatever they are, right? So if I go back to execute get all and ingresses, you will see this is not everything it created, but you can see that it's working, right? I got more than before, right? Because if you remember, policies forced me to enable scaling. So this time I got horizontal pod autoscaler as well, right? And now the number of replicas is set to 2. And they're still all failing, right? Because I solved the mechanism I added better way how to propagate what I want, the desired state, into my platform, which is a Kubernetes cluster with stuff. But it is still failing because we still don't have an image. No image is yet built. So everything else is working. Database is up and running, except the pods, because we have no image. So far.
So far what we have is an app team can use this app claim and create it and push it to a Git repo. App claim. And then then Argo picks that up. And then Argo creates an instance of a running instance of the app claim.
Yes.
And make sure the state stays in the way that the app team defined it.
Correct. And then crossplane composes from that app claim all the resources needed, whatever they are.
And Kyverno makes sure that you don't make anything outside of the policy you created, your organization specific policy.
Because here's the thing, that Argo running in the cluster, even though it's inside of the cluster, it still goes to the same API as when we go to that API externally, right? So basically all the rules, all the policies that were enforced when I do kube control apply are enforced if you do it from Argo as well, because Argo goes to the same API and does the similar calls and so on and so forth. So policies are, by adding policies on the API level, you say, hey, this is the policy and I don't really care how somebody interacts with that API. Is that interaction with Argo or directly with kube control or with something else? I don't care. Always enforced.
Anything going through Kube API is being watched by Kyverno.
Yes.
Well,
and the beauty of Kubernetes is that there is no option not to go through the API. Whatever you do, you cannot avoid going through the API.
For the Kube API server, yes. Got it. And so now our application team's experience is that they have to know that this app claim resource exists. They have to have some documentation somewhere about how they fill it out and what they do. And then they have to manually apply it to a Git repo, and then they could have the resource that they want.
Yes. Since I did not put any RBAC, role-based access control, they could theoretically apply it in any way they like right now.
Yeah.
They could continue using kube control, right? Right now, Argo CD Git is optional. If I would enforce the access control not to allow you access, then Argo CD would end up being the only interface, or Git to be more precise.
Which is desirable, and part of the point of using Argo CD is to make sure not anybody can affect the cluster easily. It's more of a break glass scenario. Like a few privileged people should be able to access the cluster to be able to fix something. But for the most part, we don't want anyone messing with our cluster.
Yep.
And so, okay, so that brings us to the next choice where we want to talk about using a web UI or a GUI or a graphical user interface. Is that the next one? No, the next one is it's one-shot actions. I'm jumping ahead.
Yeah.
Yeah.
And I noticed that actually it's picking up, kind of like everybody complained about me calling it one-shot actions, and now you're starting to call it a one-shot actions.
It's something that needs to, like, there's stuff that just has to be imperative. There's stuff that needs to be done once and only once.
Correct.
These things they're going to get triggered by something. They could be triggered by an event, like pushing code, for example. They could be triggered by time, like a cron job. And so I think that when we talk about one-shot actions or things that need to be done one time, I think the like quintessential example is building a container image. And one thing I needed you to describe to me during the episode, or Abby actually was the one to talk me through it, was why do you need this one-shot action if what you're making is not an application but a piece of infrastructure? What if the capability you're providing is a Kubernetes cluster? Why do I need to worry about one-shot actions?
Let's say you want to run tests.
On the infrastructure configuration.
Yeah, I mean, I just created a database with some stuff there, some schema, and I don't know whether it works or it doesn't. I have no idea.
And it would be great to find that out before you do
it. Would be, yeah, in general, as a general rule, it's very good practice to have some information whether it might work before you put it to production. Not enforced always, not followed by everybody, but kind of, it would be nice to know whether it works.
Yeah. Another one is checking for application updates or like dependency updates. And so that might be on a cron job. Like every day I'm going to look and see if there's a new version of Kubernetes. And if there is, then I'm going to build a new VM image or whatever.
Correct. Or, another one would be that you want, actually dependency updates could be also, hey, there is a new release of PostgreSQL. Maybe we should update our manifests. Mm-hmm. That's a one-shot action, right? Kind of like you want to change some value in that YAML. No matter whether it's executed through one of the tools we're going to go through today or manually, and then you do kube control, git push, it's still one-shot action. I want to change the version of my database.
Do you consider one-shot actions to be an integral part of platform building?
Yeah. I never saw an organization that only deals with managing state. There is always some one-time operations or actions or workflows, something that needs to be done outside of managing the state. I never saw a case without.
And then, does it have to be part of the platform? Can it be like at the GitHub level? I guess GitHub Actions is one of our choices where like code is pushed and then it's tested before image is built. Is that a platform thing?
Your platform are the services that you use, right? And if people are happy with third-party services and they don't need any abstraction or any help with them, then yeah, GitHub Actions, you can use them as is, but then they become part of your platform, right? Platform is not only what you build, right? It could be the third parties that you bring to it and say, use it as is.
So, okay. So the three tech choices that we had are Tekton, Argo Workflows, and GitHub Actions.
Yes.
So basically, by the guest's admission, Tekton and Argo Workflows, they said are basically the same. They both have been around a long time and have grown so much that their feature set has converged. Do you agree with that? I feel like you're not listening. But
no, I'm not, but I agree. I just remember that I need to set it up. I forgot to set it up, but I agree 100%.
You spent too long doing every type of policy tool and forgot the one-shot actions.
There we go. Now it's set up.
So
Now,
so basically,
I will, there is a difference between sometimes I don't even pretend that I'm listening to you, and sometimes, like now I'm in a different point, I will pretend that I'm listening.
I'm going to ask you a direct question. Is there a difference, or what do you think the difference is between Argo workflows and Tekton?
I don't, conceptually, they all do the same thing, and here is the format in which you specify what you want to execute. This, and then this, and then this, and then that. Different formats, sometimes YAML, sometimes JSON, sometimes Java, sometimes whatever. They all do the same thing. Sequential or parallel execution of tasks specified in specific format, whatever the format is. I don't even make a difference. Now, if you go more detail, yeah, I would say that Tekton has better integration with the ecosystem outside Tekton itself. It's a bit more painful to configure Argo workflows. In this case, I actually gave up for this demo today, even to configure it to be triggered from GitHub, because it's just painful. So I will be doing it manually.
That's interesting because it's Argo. Like, you think it would work well with Argo CD.
Yeah, but I don't want it to work well with Argo CD. I want it to work well with Git, because I want to push some changes to the code to Git. And then I want, in this case, GitHub. And then I want GitHub to tell Argo workflows, you know what? There was a new commit to this repo. Run whatever you need to run. Nothing to do. Actually, Argo CD will come later.
So what you want is you make a commit to the Git repo, and that's what triggers the pipeline. And
yes, in this case, yes.
And then the Git repo itself is updated with whatever new thing, and then Argo picks that up.
Correct.
Argo CD picks that up. Okay.
Yes.
The reason you would use Argo workflows or Tekton instead of GitHub Actions are a couple reasons. One is Argo workflows and Tekton is bring your own compute, and they're both Kubernetes native. So if you have more sensitive workloads that need to be, you can't just, GitHub Actions will provision its own ephemeral machine to run your whatever, which is very convenient but less secure. So if you need to use the security, Argo workflows and Tekton are better for secure things.
Slightly. Small correction. You can use whatever, I think it's called the agents or something like that. You can run GitHub Actions in your own infra as well. You don't have to use SAS.
Oh, yeah. That's true. Yeah. That's true. And then, but if you are running your own, then since Tekton and Argo workflows are Kubernetes native, you can leverage the Kubernetes scheduler to use that compute.
You can also do it with the GitHub Actions. Okay, I'm now in the mode.
Oh, you can fight me, but I'm just repeating what we talked about during the episode.
True.
Yeah, so I feel pretty confident about what I'm saying. Yeah.
Now, I will feel disappointed if you don't repeat also the closing remark from the guest.
It was Matteo, and he said, I don't know, what did he say?
Yeah, it was kind of the question at the very end of the session was...
Why vote for your technology?
Yeah, and he said, because both Tekton and Argo workflows are using GitHub Actions to build themselves.
Yes. Awesome. So I think we probably covered it enough. Is there more that we should say about one-shot actions, do you think?
No, it's, most people know it. It's basically what people call pipelines or CI.
Yeah, we've been doing CI for a long time, long before this Kubernetes baloney, right?
Oh, yeah.
Yeah. So let's see the demo.
Let's see the demo. Okay, so here I have Argo workflows definition that will do stuff. And I will go briefly because it's not big, but it's not small either, right? Some arguments like this is the default repository, this is the registry for my images.
We can't see your screen.
Oh, I think that might make it more interesting, but okay. So this is Argo workflow. And basically it has some parameters like this, the default values that can be overwritten. No big deal. Now here what I'm doing is, actually, using templates within templates. So you can see by the name, I'm going to check out the code. I'm going to generate tag for the new image. I'm going to build the image, and I'm going to use Kaneko for that. And then I'm going to run some unit tests. And then I'm going to execute a command that will basically update my manifest, the one that we saw at the very beginning, so that the tag field is now correct with the tag of the image we built. And I'm going to push that to back to Git, right? And all those are kind of invocations or templates. Templates are below, like, hey, how do you get a tag? I'm just doing the date as a tag. How do you check out the repository where git clone? How do you push to Git? Well, git push, and so on and so forth, right? So it's basically a lot of shell commands that are doing things. But in a nutshell, clone the code repo, run some tests, build the image and push it to the registry and update the manifest and push that updated manifest to Git. No deployment, right? This is now decoupled from deployments because Argo CD, the moment we modify something in Git, will kick in and do whatever needs to be done. And now this will take a while. Probably a couple of minutes, because some of those images are on the big side, so it takes time to pull them. But eventually, there you go. You see, it generated the tag. Now it is checking out the code. And then, a couple of minutes later, by the way, there is UI here, just to be clear. I can actually show it. I can do port format and then open it in a browser and then show you that I did not put certificates, but I'm going to proceed anyways. And right, this is the web UI that essentially shows you the same what I'm showing you in a terminal, right? Those two tasks were executed so far. Now it's doing the third task. Those two will run in parallel, and eventually it will finish, and we will have it tested, built, pushed, and manifests updated so that Argo CD takes over. And this will take probably, I know, I'm an idiot. I just pushed the second, or initiated the second build of the application, right? Now, okay, let me stop boring you, right? Instead of running it twice, eventually it will execute whatever needs to execute, and a few minutes later, it will finish.
So is what you're building just updating application configuration? Is it the same as, is it meant to be like, oh, the app team pushes some code, some application code, and it builds a new image, and then that updates the app claim, and then that fires off the...
More or less. So in this case, I'm running it manually by saying Argo submit, run it, right? Mostly because I did not want to fight with Argo workflows and GitHub to connect those two. But in a real world situation, you would not be executing this command. Where is my terminal? You would be, GitHub itself would be notifying Argo workflows to do it for you.
Well, I guess I was trying to understand, in a real world use case, are they more likely to be updating application code or updating application configuration?
No, application code, right? So So you would change configuration when you want to change the behavior of your application. So let's say that I made the decision that I should disable horizontal pod autoscaler, right? How would I do that? By changing that manifest myself and pushing it to Git. Now, but most of the time, you don't change the manifest. You outside of changing the image itself, right? So you would be very frequently updating it by just changing the tag, and that should be in pipelines or oneshot actions or whatever we call it automatically.
So what I've drawn is an application team pushing application code to a code Git repo, which triggers Argo workflows to build a new image and update application claim with the new image. And then that goes to the Git repo that Argo CD is watching. And then Argo CD creates a cross-plane app claim, which creates all the different Kubernetes resources needed. And Kyverno,
correct.
Sure, it's good.
Yeah.
And that builds an app image. Okay, we're moving along. So right now, our application team, all they're doing is pushing application code, and then they're getting everything that they need is being made in a safe way.
Correct.
And now somehow, I mean, to me, pushing application code seems pretty sweet. So why do we need a graphical user interface instead?
I mean, do you ask for other people or asking me directly?
Why do other people think they need a graphical user interface when it's so easy just to push code and get what you need?
I was prepared to say you don't. Because people, it's more comfortable really for the things that you're not deeply familiar with. Mm-hmm. Actually, let me split those into two different parts, right?
Okay.
What we do, we either write some code or we observe the outcomes of something, right? And when I say write some code in this context, I mean, by code, I mean anything that can be interpreted by machines, right? So, and that includes writing YAML. I'm not entering into discussion how YAML is not code. Interpreted by machines, in this context, I call it code. So you write some code or you observe the state of something. Now, I have zero doubt that more often than not, observing the state of something is better through graphical user interface. Going through logs, seeing the statuses, some graphs, and whatever people use, very nice. For writing code, I'm not sure, but people like it, including YAML. And then they might want to use graphical user interface for that as well.
So in this case that we're building for You Choose, the graphical user interface is more about observing what you've created after you've gone through this process. It will be about using the web interface to create a thing.
Today it will be for both. I'm judgmental for one of those two, but we'll do both because I'm a nice guy.
We'll do both regardless. And then, yeah.
Especially since actually the way how I did it makes it close to zero effort to do it. So kind of like, why not? And then if somebody prefers to do both, cool. If no, still no effort on my side.
So graphical user interfaces can be used in two ways. One is for if an app team wants a Kubernetes cluster or identity provider or whatever, and they just don't know what's available to them. And so maybe that graphical user interface is a way for them to A, know what's available, and B, have education around the different things you can configure about it or what the company policy might be, that sort of thing. So that's like discovering it and making it your first one. And then it's also about once there is a bunch of stuff made, the app team or other people, operations or like a VP type person can see what's been made and have a single pane of glass of everything that's going on.
Yes.
Those are the two reasons.
I mean, there are probably more, but two that come to my mind, yes.
So we want it to be able to discover all the resources that exist, regardless of whether those resources were created through the graphical user interface. Like if this resource is being created from pushing application code, even if the graphical user interface didn't create it, I want to be able to see it as part of my single pane of glass.
Yes.
Another thing about it is I don't want to be I want to have the education available to me for the first time I make something, but like the 100th time I make a thing, I don't want to have to click through the clunky interface every time. I want to have a fast way to do it, whether that's pushing code or through a template or IDE plugin or whatever.
Yeah. I mean, depends. At the end of the day, it depends on the person, right? Some people end up using graphical interfaces forever. Some people use it to get familiar with it first and then drop it for, VS Code or whatever they prefer. Depends.
Okay. And then our technologies that we covered were Backstage and Port. What differentiates those two from each other?
The first and the most obvious one is that one of them, being Backstage, is open source and in CNCF Foundation. Port is a commercial software as a service type of solution, right? So that's a big difference.
It's a big difference, and it's important because whatever technology you choose is going to be a big part now of your platform. And if it's owned by a single company, you can be surprised by license changes or some such thing. And if it's owned by a foundation, that's less likely to happen.
Yeah. I mean, in case of Port, you will never be surprised by license changes simply because it's not open source, so you don't even know what the license is. You might be surprised with with new pricing.
Yeah. And you could be surprising changes can happen, as opposed to another cool thing about something that's open source and in a foundation is there's probably a large community of users behind it that are also building integrations that you're interested in people to talk to. Yeah.
I believe that I haven't checked it lately, but last time I checked, Backstage was the third or the second most contributed project in CNCF landscape. Just behind Kubernetes, which nobody can beat Kubernetes, right? Because it's Kubernetes. So it was, at that time, second place was a fight between Backstage and Hotel. And
one thing,
No, the reason why I'm saying that when you said large community, that's large, kind of like really large.
So this graphical user interface can also be called a portal, and sometimes people say IDP when they mean portal, and those people are wrong. IDP is
actually
platform. Yeah.
If you say it without writing it, it's wrong both internal developer portal and internal developer platform.
It's identity provider.
IDP originally acronym is for identity provider, exactly. Now, if you read it, you can say you can get away from it because D in identity provider is with lowercase letters, and with IDP, like platform, is uppercase letter. And in none of those cases, so I can say that somehow internal IDP being internal developer platform makes sense. Somehow, not fully, but okay. But internal developer platform, portal, total nonsense.
Total nonsense.
Total nonsense.
Another thing that Scott Rosenberg represented Backstage, and one thing that he said a few times is that Backstage is not a portal; it's a framework with which you can use to build a portal. Is that not true of Port too? What does he mean when he said that? Yeah.
I mean, in both cases, look, in both Port and Backstage, out of the box, you're not getting everything you need, or almost nothing, right? In both cases, you need to define what it means for you to have a portal, right? And there are some tools that help you with that, and so on and so forth. Now, a big difference is that with Port, you do it through normal means, whatever normal means, right? While in case of Backstage, you're really writing code, you're compiling it again, you're building. So basically, it's both do the same thing that lets you define what you want, but from very different perspective. Backstage more focused on this is a project, right? This is project in a GitHub repo. While port this is a product, right? You can configure it, but you don't need to deal with stuff there.
So with port, it's low code, no code is what Sebastian, the guest, said. And with Backstage, you need to know JavaScript to be able to build your portal.
You need to know TypeScript to be more specific.
TypeScript.
Yeah, that's changing slowly. So I think that eventually Backstage will get to the point where configuration is only YAML. No need for TypeScript. But then if you're building plugins, then of course you need TypeScript, right? Just as you need Java if you want to build Jenkins plugin. But configuration and setup will be TypeScript-less one day, whenever that one day comes.
All right. What else do we need to say about GUIs? Anything?
No, it's pretty colors.
Pretty colors. Let's see the pretty colors, Victor.
Actually, yeah, okay, so it's Backstage, right? Now, this is the Backstage is a bit disappointing because it has less colors than most other solutions and not really pretty. So, can I say pretty colors for this, Whitney? I don't know.
They're two.
There we go.
Enough. Yeah.
But you can customize it. So basically, it's what Scott said. You can make it look any way you like. Anyways, I have one. So first of all, I'm using Scott's plugin that does two things. First, it detects what you have in your cluster. All those things here were ingested automatically from my cluster, right? Now, since I prepared this in a way that it could work both with Kubevela and Crossplane, it ingests everything. If I was building it only for Crossplane, then it would be ingesting not everything, but only Crossplane resources. You can filter what it ingests, right? And it detected that there is CNCF demo app, right? And it shows me some information about it, which I didn't configure. It figured out that there are Crossplane resources there. It created a claim and some resources, and it figured out the graph, right? Okay, so this is what you created, and that something created something else, and that something else created something else, right? So it's through the plugin, you get integration with Crossplane. It works awesome. So you can see the state of stuff. Not necessarily everything, simply because I didn't configure it fully, but you can. Now, the second part is that and this is the cool thing about Kubernetes API, right? Building APIs. APIs have schemas, and in Kubernetes, those schemas are discoverable, right? So Backstage with this plugin went to my cluster and consulted with the cluster. What is the stuff you can do in this cluster? What are the schemas of those APIs that you created earlier? And if I click create, you will see that it discovered that there is something called app claim, there is something called GitHub claim, and there is something called SQL claim, right? So it discovered, I did not have to tell Backstage as traditionally you have to do, if somebody wants to do this, those are the fields and blah, blah, blah. It discovered what I can do, and now a developer can go, tell me something, do you want application or GitHub repo or SQL database? Whitney, choose.
SQL database.
There we go. Choose, right? And then typical stuff. What is the name? What is the namespace where you want it? Who will be the owner of that something? Admin, I think I should have configured that. There we go. Next. And then it has the fields. What is the ID? And there are some parameters like what is the region? Do you want to use database schemas? Do you want to apply database schemas? If you want, you click the button. Do you want some Dapper components? Do you want this? Basically, it converted the schema into a form that I can fill in and click the button, right? Now, some fields are mandatory, so I did not fill them in. More. There we go, right? The point now, apart from showing me the form, the way how it works, is that if I would reach the end of this process and click create, it would not go back to the Kubernetes cluster. It uses Kubernetes cluster only to discover schemas and resources. If I would finish this process, it would go to my GitHub repository and it would create a new, either create or update YAML and push it to Git. And then Argo CD would pick up, right? So it's a read-only plugin that only discovers what's in a cluster, pushes results of what your forms back to Git, and then Argo CD or Flux synchronizes it into the cluster.
I am following and drawing terrible pictures. Actually, they're not bad pictures. So this is what I'm hearing and drawing. So with our backstage, our application team can find stuff, they can make stuff, and they can see what they made, right?
Yes. And
also,
what they can see, what they can make, what they can find is not hard-coded anywhere in Backstage. It's discovered through Kubernetes API.
And that's what I was trying to draw, this big blue arrow going behind everything.
I think you need new markers.
Yeah, the blue has never been good. I almost never use it for that reason. The Backstage discovers through API, but the application team, they can still directly push code to the Git repo. They don't have to use the GUI.
They don't.
But if they want to, they can make it through the GUI, and then the GUI just goes to the Git repo. It doesn't actually go directly to Kubernetes. It's still doing the same thing in the end.
No. If I don't implement RBAC, they can also go directly to the API. And I think that that's the point, is that it's always API, directly or through some tools like CLIs, kube control, or through Argo CD, or through Backstage, or through Backstage indirectly through Git, and then Argo CD. There can be one or infinite number of paths, but they all lead to the API.
Yes, they all lead to Kubernetes API server. So it might not go to Git repo code. It might go to Kubernetes API. What matters is it eventually gets to Kubernetes API.
Yes. And
so now,
that is in a spirit of, let's say, AWS, right?
Uh-huh.
AWS never said, oh, you can use our services only through our web UI, right? Said, no, we have API. You want to use Terraform, go for it. You want Ansible, go for it. You want AWS CLI, go for it. You want CloudFormation because you're a masochist, go for it, right? You can have potentially infinite number of ways how you can eventually get to API. That's why I said that in a way, Argo CD is optional, not because I don't think it's amazing. It's amazing. GitOps is amazing. Everybody should use it, right? But API is what's mandatory. And then how you interact, you can have 1 or 1,000 ways to interact with it.
So what we've built so far, and really, period, is app team uses the GUI to make stuff. And that make stuff updates a Git repo. Which maybe your demo isn't quite this complex, but we make stuff, and this Git repo is the code repo. And from that code repo, with workflows, we build the app image and then push an update to our app claim resource that's in the config Git repo. And then Argo CD is watching that one and picks up the change. And then Argo CD applies the changes to the Kube API, which Kyverno is watching to make sure they stay in policy. And then that app claim, cross-plane app claim, gets applied to the Kubernetes API, and then Kubernetes makes all of the resources, both inside and outside of Kubernetes, associated with that app claim.
Almost.
Uh-oh.
You have 2 repos there, if I got it right? You have app repo and GitOps repo, right?
I have a code repo and a configuration repo.
Okay. In that scenario, Backstage would be pushing to the GitOps repo.
To the config repo.
Yes.
Yeah. So what's the app team creating through? They already have their image in that case.
Yeah, you're just changing the image. So image is built when you make changes to your code, right?
Yeah.
So you would have that app team using VS Code, let's say, or IntelliJ or whatever. They write some code, they push it to the app repo, and your flow works from there, right?
Yeah.
So basically, that line from app team to the Git repo, that would be for code, right? And Backstage would be going to the other repo, really.
And realistically, what would an app team be going into Backstage to?
Two things. First, to create a new definition of an application, right? Probably only once. Maybe later on if they want to change something like auto-scaling, right? And second is to see the state of something, right? Oh, is it working?
Right.
Where do I find that information? So it's operations in terms of generating or updating manifests themselves, and observability reasons to see the status of something, right? The state or the actual state. Now there are others. Now this is in this example with Crossplane plugin. Let's say that we extended Backstage with the Argo Workflows plugin. Then their pipelines, those that are testing and building images, they could see them also from Backstage, right? So think of Backstage as a place from where you can observe theoretically anything.
We have all this mess going on, and we want to have one place where we can see it all. And Backstage
there is
that place.
Scott himself, for example, also made Kyverno plugin, so you could see the information from Kyverno about policies that made you suffer.
Why won't this run? And figure out and Backstage through the Kyverno. Here's something about GUIs too. All of these tools have their own GUI. Argo Workflows has a GUI. Kyverno has a GUI. Argo CD has a GUI. Crossplane doesn't make a GUI itself, but somebody made one called ComoPlane. Like everything already has one, but it's so much easier to have that all in one place.
Correct. That's the main premise. That's really how Backstage started, right? I would be surprised. I don't think that actually even term internal developer platform existed. That's relatively new. I mean, platform existed forever. But yeah, the point for Backstage was how can we have one place that is acting as the entry point to everything else? And that's to be pretty colors. Now, if I could be nitpicking, that app team can be pushing directly to the, in theory at least, whether they should or not is different. They could be pushing to the other repo as well.
Yes. And what I was trying to build is what you actually built, not what's possible.
Well,
Because
I can tell you that I couldn't draw what I built or possible myself, so I get lost in it. So I don't know how you did it.
The application team could manipulate through Backstage. They could push to the code repo. They could push to the configuration repo. They could access API directly if we don't have our back set up. We could also supply other interfaces to them because this Crossplane app claim is behind an API. We could make it available as an IDE plugin. We could.
It could be plugin in VS Code. Yeah.
Yeah, it could be. In the end, it could be wrapped in a lot of interfaces. And when we talked about talking to the app teams at the beginning to figure out what capabilities you should even be making, part of what you should be talking to them about is how do they want to consume that capability through what interface? Because that part is
after you build the API. So you build the API to define what it is. And then, the answer could be we don't need anything, right? Or we need something to wrap it up, make it more user-friendly. Yeah. And that something can be one thing or 10 things. By the way, if anybody has questions from the audience, shoot.
Yeah, don't be shy. We're actually, what are we, an hour and a half in? We're getting through this quicker than usual, I think. I'm a little surprised. And I'm having a lot of fun. It helps me to put it all in one place and to draw it out. So...
By the way, we have in London, we will have 25 minutes, right?
To tell this story.
Yeah. Good luck to us.
Victor and I are speaking at KubeCon. I don't even know what day we're speaking. But come hear our Choose Your Own Adventure.
Yeah, Whitney will bring the light board.
If only. Okay, so we do have 2 more episodes that we're going to talk about, but we're not going to draw anymore, or you're not going to demo anymore.
No.
Because they're basically they're projects that aren't integral to this story. They might help in various ways, but they're not necessary. So the first one is an episode we called Specialized Templating, which was a bad name. You don't want me to be...
I know. I thought that you're not doing the light board anymore. Sorry. Then I remember that you have to be on a light board even if you're not doing it. Cool.
Yeah, I could set up.
It's fine.
We're here. It would take too long. Thank you, Conrad, for saying the light board is nice. So we did one called Specialized Templating, which was a terrible name. And what we went over really 5 projects, and they all, in their own ways, were trying to help grease the wheels in between the application developer and operations. They're all trying to abstract away parts of operations and make it easier for application developers to deploy what they need to.
Can I say something unpopular that I didn't say in that episode?
Always, Victor.
I think that they are almost mutually exclusive. With Kubevela crossplane Crocratics.
Oh, if you're building APIs, you don't need any of these 5 tools that...
Yeah, kind of like, do I need to abstract abstraction that I created myself? So kind of the whole goal is to actually have something very simple and easy by building those specialized APIs, right? Or custom APIs. So I'm not sure how useful it is to wrap those up more, because if you need to wrap them up, I would say that maybe the API you designed is wrong in the first place. I think that they are more appropriate for the scenario where you're not building your APIs, which could be a valid one. I'm not arguing kind of now.
Yeah. And maybe that's our flaw, where we should be putting it somewhere else in the overall story of the CNCF.
It's almost like that we should have started this with the debate, should you build your own APIs or use existing lower level APIs and wrap them into something other than your own API, right? So maybe it should have started from that, and then people choose one or the other, and then we do Crossplane, Cratics, Kubevela, or those.
And then if you choose those, then our story is over quickly. But so then...
Yeah, if you choose those, then I reject to kind of continue with the season, and we switch to whichever is the next one.
So the one that won is Porter, and it was meant to wrap an application in like package full Kubernetes applications. But different.
Yeah, but Port is kind of special.
Porter.
And no, sorry, what did I say? Port? No, which one you mentioned?
Porter.
My brain froze. Huh? Porter.
Porter. Yes.
It's kind of, yeah, you can, but it's more that you can, yeah, of course you can wrap your application similar way to Helm, but I see it, and I might be wrong because I'm not a heavy user of it. It's more that you can wrap operations, right?
Yeah.
I can create this cluster locally and then apply this to install that and so on and so forth. So it's more about wrapping operations, I feel.
Like
than
installing
wrapping
things
the
and
definition
running
of a
scripts.
state of something.
Yeah, installing things and running scripts. But in the end, having an artifact that you could hand to someone and then they could just run it and have the complex infrastructure
Use
that you
case,
want them to
what I
have.
really wanted to do with Porter, which I didn't have time, if I did, I would do a demo where actually, all the commands that I was executing so far, and those that I haven't been executing because I did them in advance, I could have done them with Porter.
Say that again.
All my scripts and commands that I was executing outside of this stream as a setup and during the stream, I could have wrapped them into Porter.
Yeah, that's totally
I
what you're supposed
think.
to do.
Yes.
And then we talked about WERF, WERF, which is a tool.
Sounds like birth. How do you say when you... Is it birth?
barf, like a throw
Barf.
up.
Yeah. Barf. Birth. Birth. Anyways.
Victor. Yeah.
I'm not making friends, I know. It's a tool that does a lot of things, right? A lot. I cannot even follow everything it does.
Yeah, it somehow helps Helm, Kubernetes, and Git all work together more easily. Like these three quintessential tools that are always going hand in hand, it somehow builds on top of that. It makes an abstraction to help them be easier to use together.
So that one also does not follow my initial description of the tools in this. That are instead of APIs. This is more like a wrapper of many things. Yes.
And then we have Radius and Score, which were kind of similar to one another, but Radius. So you define Score is supposed to be a specification, but you define a workload, and then this workload should be able to run anywhere. Like you define once, run anywhere. But Score was more about remote versus local, and Radius was more full-fledged.
Yeah. Now those two fall into that category I was saying before. I feel that you would use them if you're not building your own APIs, right? Because basically everything I did in this case with Crossplane, you could wrap it on the client side through Radius or Score, at least in theory, kind of, and say, hey, I'm not giving you API, kind of like you just run this thing and that thing will do whatever needs to be done.
Exactly. I'm not giving you an API, but instead I'm telling you this is how you define your app. And then with this definition, the ops side could take that same definition and do whatever they need to do with it without the application developers needing to worry. And then the last one is Pipe CD. So what he said during the talk that stuck with me is like what Argo CD does for Kubernetes, Pipe CD does for any target.
Yeah, kind of. It's another one that I haven't used, only briefly, so I'm not very familiar with it, but I understood that it's basically like GitOps, not only for running in Kubernetes.
Yeah. So those were the 5. Y'all voted Porter, but Victor hasn't had time to put it together, and that's okay. And then we had our miscellaneous episode, our final one, and we talked about 3 technologies as part of that. The first one, it was Fusion Stack. But really, he talked about Carpor, which is one of the tools in Fusion Stack.
Yeah.
Which I thought was really cool tool, actually.
Yeah.
All of these I thought were pretty amazing. Yeah.
Yeah, Carpor is cool. Not necessarily something that it aims to replace your Kubernetes dashboards. I don't think it's there or even close, but it has a really cool feature that it synchronizes all information from all your Kubernetes clusters into a central database so that you can search stuff, so that you can navigate stuff, so that you can treat fleet of your clusters as a single entity, right? Very cool.
You can search multiple Kubernetes clusters at once, which is a big deal. Then the other one was Dapper. That might fall into the category of if you're using Dappers instead of building all your own APIs, maybe?
No.
No.
No, it's more about, at least Dapper I know from before. I'm not up to date with what they're cooking now, but it's more like, how can we abstract communication from your application to something? So let's say that, hey, a database, right? And database, if your application is running in staging, it will be connecting to a different database than if it's running in production, or maybe there is some pub sub and so on and so forth. How can we let administrators do the heavy lifting of figuring out what goes where, and you as a developer, you just say, I want a database. I want to connect to a database, right? So if Crossplane would be managing the database itself, Dapper would be figuring out, okay, so this is the right database for you. No worries, no need to think about it, right? Kind of like, I'll figure it out for you.
Yeah. So like with Dapper for a database, Dapper provides lots of different building block APIs, but a database API. So you would use a Dapper database API and you would treat it as any database. You don't care. And then in the back end, the platform engineering team is actually deciding what is getting implemented behind that database API. And Dapper has a bunch of maybe 15 or something, a lot of different Dapper APIs that you can use that then the platform team implements whatever they want behind it. And apparently, if the platform team changes their mind and wants to switch out the database on the application team, I think the application team doesn't even know the difference.
Yeah, exactly. So kind of, I just go, my app is talking to a database. I really don't know where and what and why and stuff like that. I don't care. And I'm using database as an example, right? As you said, there are different type of destinations.
Yep. Cool. That's Dapper. And then the one that won the vote was Open Feature.
Oh, yeah. Open Feature is cool.
Tell us about Open
I
Feature.
mean, Dapper is cool as well.
And
Open
so
Feature is
Firefox.
basically a standard for feature flags. And feature flags are how to enable or disable parts of the code so that we can do some funky stuff like, hey, I just have this half-baked feature. I can still deploy it to production and disable it, right? Or I want to enable this feature only for the subset of users and so on and so forth, right? So it's how to enable or disable based on whichever conditions we want specific parts of the code, or specific features, right? Yeah, and then that's a specification, right? And there is a sample implementation, but then just as with Dottle, right? It's first and foremost a specification, and then there is an implementation of it, not necessarily the best one in the world, but then all other vendors are supposed to change how their tools work to follow that specification, so that I don't need to think about it, right? So I can define open feature, I can define everything I need in open feature format, and then say, I'm going to use this tool instead of that tool, but doesn't change what I did, right? Or at least that's the idea.
And I asked you at the time, and like Open Feature is a way to enable and disable parts of your code within an application, as opposed to progressive delivery when you're kind of choosing between different container images. But to me, they're similar-ish, but kind of at different levels in the stack. Yeah?
Yeah.
We do have a question. Hello, Dennis. How does Scott's plugin know where to push a manifest in the GitOps repo? It might have some structure. It can't just be raw manifests.
Yeah, so where to push manifest, you can configure it on the Backstage level. When you configure Backstage itself, you can say this is the repo. Or users, if I'm not wrong, can select in that form one of the repos, and they can also specify where, in which directory of that repo, and things like that, right? So there are two levels, right? User input or configuration that you put on Backstage itself.
Awesome.
Yeah.
Victor, I think that might be a wrap. I think that's the end of chapter 5 of YouTube.
Yeah. We did it.
See, we built.
This
we
was a
built
test
this.
run. Now we saw that we are 1 hour and 45 minutes. We need to trim it to 25 minutes for KubeCon.
We got this. Come see us crash and burn. If you're going to be in London, have a good time with us. And,
Yeah.
And we'll see you in the fall. Do you have a thought about what next season is? We talked about automation or scaling.
I have no idea. That.
Something. We'll be here. We'll
We'll think about it after KubeCon.
after KubeCon. Awesome. Well, if you're in London, please say hi. And if not, have a great few months. Talk to you later. Bye.
Bye-bye.